Do you feel the vibes?
Hi, okay, so this is a recording for lesson 10.3, sequences and series, but this time we're going to look at geometric sequences and series. In 10.2, we looked at arithmetic. This time it's going to be geometric. And there are lots and lots of parallels and similarities, so it's just going to be very, very similar. Right, so a geometric sequence, unlike an arithmetic sequence, is one where the ratio between successive terms is a constant. And that ratio is called the common ratio R. So for example, if you have your first number is 5, and then the second one you multiply by 2, it's 10, then you multiply by 2, it's 20, then 40, and so on. Each time, 10 over 5 is 2, 20 over 10 is 2, so there is a common ratio, not a common difference. All right, so let's see what the common ratio is here. Remember, we always want to do the second term divided by the first term. So in this case, 9 over negative 6, it's negative 1.5. Right, so if you want to say negative 3 over 2, it's fine, it doesn't matter. But since it looks like everything is in decimals, let's just go with decimals. So the next three terms, right, it's going to be negative 13.5 times negative 1.5, 20.25, and then 20.25 times negative 1.5, negative 30.375, and then the last one, you kind of do the same thing, 45.563. So those are the next three terms. Right. So what about this one? Here we have an expression, right? This is A1, this is A2. So R will be A2 over A1, negative 81n plus 243 over 243n minus 729. Well, let's see. Okay, so it looks like I can factor out a negative 81 from here, and I get n minus 3. And it looks like I can factor out a 243 from here, and I get n minus 3, right? Because we all know that, right? Yes, of course we do. Okay, so n minus 3's cancel. I have negative 81 over 243, which also reduces, so R is negative 1/3, right? So then A sub 4 is negative 1/3 times the next one. So that's negative 9n plus 27. A sub 5 is negative 1/3 times negative 9n plus 27. So that's 3n minus 9. And then, did it say to find the next three terms? Yeah, A sub 6 is negative 1/3, 3n minus 9. That's n minus 3. Okay? All right. So, again, we can find an explicit formula for this. Let's go with that example above where the first number is 5 and we're multiplying by 2 each time. So your A1 is going to be 5. A2, 5 times 2. A3, 5 times 2 times 2. A4, 5 times 2 times 2 times 2. And so on all the way to AN, right? Well, what do we have here? Here I have 5. Here I have 5 times 2 to the 1, 5 times 2 squared, 5 times 2 cubed, right? And you notice that it's always 5 times 2. 2 is your R to the power of n minus 1, right? So A sub n will be A sub 1 times R to the power of n minus 1. And that is the explicit formula for these, right? So it makes sense. We can reason it out, but we also have to memorize it. Okay, so the explicit formula is A1 R to the minus 1. Now the recursive formula, you give the first value, and then each term thereafter is R times the term that came before, A to the n minus 1. Okay. So here we go. Let's write an explicit and a recursive formula for the nth term of a sequence. Okay, so for this one, a1 is -1. R is 2 over -1, -2. So the explicit formula will be an a1 r to the n minus 1. You really don't need parentheses. It's kind of understood in this format, but when you put in the numbers, then you do need some sort of a parenthesis. So a sub n is going to be -1 times -2 to the power of n minus 1. And this is good enough. The recursive will be a sub 1 is -1, semicolon. A sub n is a sub, well, let me write the r first, it's cleaner. It's -2 times a sub n minus 1. Right. Okay. And in the same way, we can do things like this. So the 11th term here, right? I have a1, I have a2. Let's find r here. Then we can find the 11th term. So r here is going to be 115.9 over 122 negative, positive 115.9 over negative 122. So r is negative 0.95. Okay, so a sub n is equal to a sub 1, r to the n minus 1. The 11th term is a sub 11. That's negative 122 times r to the power of 11 minus 1, which is 10. You're going to put that in your calculator, and we're going to get negative 73.05. It's not too crazy a number because you're multiplying by 0.95, so it's getting like smaller and smaller every time. Right, so we talked about arithmetic means. Geometric means are the same thing. They are the terms between two non-consecutive terms in a geometric sequence. So same thing, right? So let's see, write a sequence that has 3 geometric means between 264 and 1.03. Right, so it's going to be 264, and then the 3 geometric means, and then this decimal. So in total, you have 1, 2, 3, 4, 5 numbers, so your n is 5. A1 is 264. AN is 1.03, blah, 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 right? Okay, so what's our formula? Our formula is AN is equal to A1 R to the n minus 1. What we need to find here is R. That's what we don't have. So AN, the last term, is equal to the first term times R to the power of n minus 1. N we said was 5, minus 1 is 4. So when I divide by 246, this is going to be r to the 4. Well, to solve for that, I take a 4th root, plug this into the calculator. What do you know it? R is just a simple 0.25. Right, let's just plug that in to make sure. That's the 4th root of 1.03125 over 264.25. Fabulous. You don't even have to round. Okay, so that means with each step, you're going to multiply by 0.25. So this number actually becomes 66. Then multiply by 0.25, 16.5, 4.125, and then the next one. Okay. What about a geometric series, right? When you add them up. So there are also formulas for a series, right? Just like in the arithmetic, we had formulas for the sum. We also have them for the geometric series. Okay, I normally derive these formulas. I would derive it for section 2 as well and for section 3. I'm sparing you guys those this year. Okay? But here they are in all their glory. Again, we have two versions, and just like we did in the arithmetic case, one is just like the other one substituted in it. This is the first format of the sum of an arithmetic series. And here is the second format. So you see in this one, you have a sub n. In the previous one, you don't have a sub n. So depending on what you have, that's how you choose, the first or the second one. Okay, so let's see what we got here. Find the sum of the first 11 terms of the geometric series, this. So n is 11. This is the geometric series. We first need to find r, negative 1.5. So s sub 11 is equal to a1, 1 minus r to the power of n all over 1 minus r, so 1 plus 1.5. Right? So when you plug that in, it's going to be 4 times 1 minus negative 1.5 to the power of 11 all over, what is it, 1 plus 1.5, so that's 2.5, right? And before I do anything, I just make sure that, with all the parentheses, this, like the calculator understood what I meant for it to understand, and it did. So it's 139.996, blah, blah, blah. Let's go to 3 decimal places. So 139.996. Okay, let's go calculus style. Fabulous. Okay. So the sum of the first n terms, we need to find the sum of the first n terms of the geometric series with a1 and an, right? So this time you're given the last term, right? So there is a chunk, and then you have r. In this case, because we have a sub n given, but I don't necessarily know how much n is, I use the second formula. All right, so S sub n is equal to a sub 1 is negative 4 minus a sub n, negative 65,536 times r all over 1 minus 2. Right? We plug it in. Negative 131,068. Okay. All right. Here we go. So here we go. Now we need to find this one. And again, I don't like these N's and these K's, right? I hate that they use N here. I'm going to change this to K and you'll see why. Okay. So when you have this, remember when you have the summation notation, inside is your expression for a sub n. Now, a sub n for the geometric series was a sub 1 r to the n minus 1. So the thing that is being raised to the exponent is r. So here the thing that's being raised to the exponent is that number, and so that is r. That's how we can always identify what r is. Okay? And this negative 2, that's the first number. Okay. So now let's see how much n is. N is, oh, can you guys hear that? Somebody is doing fireworks outside. What the heck? It's only April 23. Wow. Okay, so n is how many numbers in here we are summing up, right? So we have this like series, right? And we're taking from k equals 3 to 8. So this is the third number, and this is the eighth number. This is the only thing we are summing up from the third number to the eighth number. So 3, 4, 5, 6, 7, 8. So n is going to be 8 minus 3 plus 1, 6 numbers. Okay? All right. The first term in this chunk is a sub 3. And that is negative 2 times negative 2, 3 minus 1. So that is negative 2 times negative 2 squared, negative 8. Okay, let's use the first formula for this one. So S sub n is going to be A1, 1 minus r to the n over 1 minus r. A1, that's the first term of the chunk that you're summing up. 1 minus r, negative 2, to the power of however many numbers you're adding, 6, over 1 minus negative 2, 1 plus 2. So altogether, 168. Okay, so let's move on. In the case of a geometric series, we can also sum up an infinite series, right? Remember we did that in section 1. We had an infinite series. We added them up. We took a sum and we got a finite number, right? In the case of the arithmetic, that won't happen because it's a linear function, right? So all of the numbers, they just keep increasing. So if you sum up an infinite number of them, you will not get a finite number. But in the case of a geometric sequence, right, we are going to get a finite number. And let's talk about why that is, right? So in the previous section for the arithmetic, we said it was an, right, was equal to a1. So do you remember how we kept getting a linear function, right? So here, right, we actually wrote it right here. We said it was going to be a1 plus nd. That's a linear function. In the case of the geometric, an is a1 r to the n minus 1. This is an exponential function. This is like y equals a b to the x. That's an exponential function, right? So in the case of an exponential function, if you have exponential decay, then each of your consecutive terms are going to get smaller and smaller and smaller. Okay? So in that case, we can add up all of the different terms. Okay. So by the same token, if you have exponential growth, then your numbers are just getting bigger and bigger and bigger, and you cannot add them up because then you will get an infinity as an answer. So if r is greater than 1, then this whole thing increases without limit, so you cannot sum it up. However, if the absolute value of r is less than 1, then it approaches 0, right? The values approach 0 as n approaches infinity, so that's when you can sum up your series. All right, so for the sum of an infinite geometric series, this is the formula. But the most important thing is, in order for you to be able to use it, r has to be less than 1. The absolute value of r has to be less than 1. All right, so here is an infinite geometric series. So let's see what r is. 18 over 24, 3 over 4. Absolute value of r is less than 1, so we can go ahead and sum this up. S, it's not S sub n anymore, right? Because this is an infinite series. It's just A sub 1, 24, over 1 minus 3 over 4. And this is definitely a non-calculator problem. This 1 minus 3/4 is a quarter. So 24 times 4 is 96, right? So look at that. You summed up an infinite number of values and you only get 96, right? Okay, so here, R is 0.66 over 0.33. R is, I could just write it here. It's greater than 1, so you cannot add these. Okay, here we go. Here, this is R, 0.65. So S is going to be A1, right? For that, we need the first term. Okay, so the first term is when n equals 2. 3 times 0.65, 2 minus 1, 1.95. So this is 1.95 over 1 minus R, and that will be 29 over 7, actually. Okay, you would get a calculator for that one, right? So this is an infinite series. It's just that we're not starting at the first one. We're starting at the second one and adding them up. Okay? All right, so that is section 3. I have one more day of review before the quiz. All right, have a good day, everybody.
Press start.